All right, guys, we're going to do a little video tutorial on groundwater. This is an introduction to get you guys to think about where water is stored underground, or how water is stored underground in an aquifer. And so Livy has two containers there that have marbles in them. One container is all the same size of marble, and then the other container has a mixture of different sizes of marble. And so what this is analogous to would be sediment that makes up rock, like sandstone, underground. And what we're going to talk about is pore space. So pore space is a measure of the empty space between particles. Here they're marbles. Underground they would be sediment or cracks within rock. And that measure of pore space gives us a sense of the percent volume of water, or the ability for that material to store water in something called an aquifer. So Livy's going to go ahead and add a little bit of water to each one of these careful. Just fill it up to the top and then stop, and then do the same for the other one. And while she's filling up the other one, you can see that the water fills in the space between the marbles. And that space is called pore space. And so what's different about these two samples is the size of the marbles. One is made of all the same size marbles. The other is a mixture of sizes. And each of those can be defined by percent porosity. So we have one sample on the left where our marbles are considered to be well sorted. They're all the same size, they fit together nicely, and therefore they have a higher porosity, or a greater ability to store water within those spaces. And then the other sample, which is a mixture of different size particles, is one in which we call it poorly sorted, because the smaller particles fill in the gaps between the larger particles. So this makes less space for that material to store water. So when we talk about groundwater, ideally what we're looking at is a measure of porosity, in the sense that well-sorted rock underground will store more water in its pores. So the higher the porosity, the greater the ability to store groundwater. And so what that looks like here is, I'm going to go ahead and just draw on here. That would be the pore space between a well-sorted sample, and here would be the pore space between a poorly sorted sample. There's less area to hold or store water. So sorting is a measure of the likelihood that a rock or sediment will act like a sponge, storing water underground for freshwater use. So that's part one of this. Part two, we're going to talk about a different idea, which is called permeability. And permeability is a measure of how easily water can flow through these pores or spaces between sediment grains. Stay tuned.